Okay. Now it's okay, man. Are you able to hear me? So with the previous architecture, what we have been seeing, it makes it very clear that in this entire Oracle architecture, the table space as a component makes a very important role. Okay, it takes the most important role. So your table space is fundamentally confirming that your entire data with respect to the Oracle's internal database requirement as well as your data is totally stored within that particular piece of the table space as a logical storage unit, which is physically keeping the data in your operating system's control with your data files. But people cannot directly go and talk to these particular data files at any point of time from the OS side. So if you want to communicate with that particular data, you need to only communicate with a language called as SQL star plus with SQL statements, and then the data will start responding to you. But technically, until and unless Oracle itself is not feeling that it is secured by itself and it is able to manage its data by itself, I don't think any great wonders can happen. Be very, very clear about that. So, starting from 10G onwards, Oracle was taking certain kinds of fundamental precautions. What it was practically trying to do is, it was trying to provide the table space construct in such a way that once you install and configure Oracle, there are two different table spaces that will get installed and configured automatically. One is called a system table space. The next table space is fundamentally called as system auxiliary table space. And the system auxiliary table space, in short, it's called sysox. Okay. So many times you find people calling that as sysox. That's okay. But in practicality, it is called a system auxiliary table space. These two table spaces are very, very important for your Oracle to run on your machine. Am I clear with you? I'm repeating once again. These two table spaces are very, very important for your Oracle to run on your machine. Physically, to make your Oracle to run on your machine as a database management system software, these two table spaces are a must. So there is certain amount of information technically you need to understand about these two particular table spaces. The first point you should always remember is the common point. The common points between system and sysox table spaces, if you are considering these two table spaces, are considered as mandatory table spaces. Means they are compulsory for your Oracle as a database management system software to exist on your machine. Am I clear with you? The second thing is, these two table spaces are created at the time of database creation. Okay, these two table spaces are created at the time of your database creation. Be very, very clear about that. Means when your Oracle is first time installed on your machine, after its installation as a software is completed, and then its database configuration is starting, at the time of database configuration, these two table spaces will be created. Once your machine is started and you want to work with your Oracle, these two table spaces, definitely they should be online always. Okay, these two table spaces should be online always. Be very, very clear about that. If these two table spaces are not online, then technically you cannot run your particular database at any point of time. Okay, so you need to just understand that in order to make these two in order to make your Oracle database management system software to operate, these two table spaces, definitely they should be online always. The next thing is, These two table spaces are absolutely used to support Oracle's internal architectural management. Any components of your Oracle, if you are expecting them to operate and they should give you services to develop your database applications, as a database management system software, Oracle's entire existence will depend upon these two table spaces. So these two table spaces will be controlling the total internal architectural standards of your Oracle. Upon a machine, if you are creating a database of Oracle, for every database that is created in Oracle, it has its own system and system auxiliary table spaces. So on your machine, let us say like you have installed your Oracle. Okay, on your machine, let us say like you have installed your Oracle and you have configured it. Then technologically, for every single database you create, it has its own system table space. It has its own system auxiliary table space. Am I clear with you? Therefore, on your machine, if two Oracle databases are configured, then you are having what? Two system table spaces and two system auxiliary table spaces. Am I clear? So try to understand these particular functionalities very clearly. Now, these are very common points what you need to understand about the system and system auxiliary table spaces. Now, exclusively, what exactly you mean by system table space in Oracle? So whenever you want to speak about your system table space, you should always understand this table space is always available when the Oracle database is open, and at any point of time you cannot make this table space to go offline. If this table space is offline, then your database management system software itself is not operating. And when your database management system software itself is not operating, then you cannot conduct any kind of database application development operations. Be very clear about that. Okay, your database application development itself cannot be done. Am I clear with you? Now, the second point what you should always remember is the system table space will be storing the entire data dictionary or its base tables, means your total metadata that is essential to manage your entire Oracle database, and in turn which is essential to manage your entire database application objects. They are totally available and they are stored within your system table space. Therefore, whenever you deal with your system table space is actually including the data about every Oracle object that is fundamentally registered within your Oracle database, which is actually called as metadata. And this metadata is nothing but it is managed totally as one data dictionary construct, means this entire metadata that is controlling your Oracle database management system software itself is called as a data dictionary. Be very, very clear about that. So whenever you deal with your system table spaces, now this table space is not actually created by you, and it is a first table space that is created as and when you have installed and you have configured your Oracle database. If this table space is not created and if this table space is not properly configured, we can forget about operating on Oracle as a database. So it is a collection of many number of tables and views that are fundamentally reflecting to your architecture of your Oracle. So accessing the system table space and the data that is existing in the system table space is possible only with higher level privileges. There is nothing but you can access every component that is existing in the system table space only when you have DBA role. Are you getting me? Only when you are having a DBA role. So the person who can access the objects and components of the system table space, generally they are the high level DBAs in your organization. So normally the developers means people who are actually participating in the core development of the project, like you are never given permissions to at any point of time touch the system table space directly. And a normal developer, a normal application developer can never rename or drop a system table space, because this table space is the most important table space for your entire database management system software to exist. So you can understand in real time how the database administrators will be highly protecting this particular system table space for the sake of their constructive operations. Now, system table space is operating on your Oracle database. Now you are keeping all your data within your criteria and composition of your physical machine. Now on an electronic device, anytime the data can be corrupted. Therefore, system table space will be managing its own undo segments. So your business data and your Oracle's internal architectural data, they will never ever be kept together. So once your system table space is created and it starts getting managed, then automatically it will try to manage its own undo segments. Be very, very clear about that. These are the main important points. At least you should speak with your interviewer when he's asking you, can you just tell me few fundamental points about system table space? Now, how to create the table spaces and all these things, as an application developer, you don't need to get worried when, because that's none of your headache. It is totally the headache of the DBAs. Now, what is exactly the specific points we need to understand about the system auxiliary table space? You should always keep it in your mind very clearly. The system auxiliary table space will be storing the data for any kind of auxiliary applications that are fundamentally in relative state to your Oracle's recovery and management. Especially there are many number of internal Oracle components that will be monitoring the way the Oracle should be operating. So system auxiliary table space, many times people think that it's like a mirror map of the actual system table space. It's not practically that. But anytime your system table space is getting corrupted, it will try to repair itself. It will try to recover itself from that particular corruption or damage by utilizing the services of the system auxiliary table space. Am I clear with you? So system auxiliary table space will be storing the data for auxiliary applications like log miner. Log miner in the sense, for every small activity you do in your Oracle database, it will be internally managing a log. Log means auditing. Who got connected to Oracle at what time and when he got disconnected, which objects he has been using, whether he's inserting, updating, deleting. This way your log will be writing everything that is happening as criteria of actions and activities within your Oracle's environment. So system auxiliary table space will be storing such kind of data that is getting generated through the logs. As your Oracle is operating, that operational internal state of information, this system auxiliary table space will be registering. it starts managing the total information about the workspace manager. It will be registering and recording the entire Oracle data mining constructs. Means, now don't get into the data mining. When I say, don't think that it's a field of data mining. Oracle itself will keep all its operational information in such a huge amount of database. The system auxiliary table space has that entire intelligence to mine on that particular piece of the event level operations that are happening in Oracle, and then technically start writing that as a criteria of information, such that anytime the system table space gets corrupted, it can reproduce that particular piece of the process, it can reproduce that particular piece of the application and recover that system table space, such that you don't lose any of your data or your database from failures. Am I clear with you? System auxiliary table space will be keeping all that information that is generated through Oracle streams and any other Oracle tools that are integrated to Oracle and that working on dependency to Oracle. All the other tools operational information system auxiliary table space will be managing. So what is the main advantage or what is the main requirement of the system auxiliary table space? System auxiliary table space is very, very important for recovery of the Oracle database in situations of failures. Whenever your Oracle database is failing, with the help of the system table space or system auxiliary table space only, we can make a recovery out of it. Am I clear with you? So try to understand these constructs very carefully. So if your system auxiliary table space is corrupted, then technically you can think that your recovery to your Oracle database is not possible. So any damage or corruption to your system table space can be recovered and it can be repaired with the help of the system auxiliary table space. So system auxiliary table space is automatically created whenever the database administrator is using one special kind of utility that is existing in your Oracle database management system software, which is called as DBCA, database creation assistance. Okay, there is one particular tool called as database creation assistant. When you are using this DBCA to build your Oracle database, automatically your system auxiliary table space will be created. Now, once again, the system auxiliary table space is used for very specific internal recovery like standardizations in Oracle. Therefore, anybody who wants to access system auxiliary table space, he needs higher level permissions. There is nothing but if you are expecting to communicate with system auxiliary table space or you want to rename or drop the system auxiliary table space, you need database administrative privileges. Therefore, system auxiliary table space will not participate in the main activity of your database management system software. System auxiliary table space is technically used to store only the system specific objects that are very, very important for the sake of recovery oriented management that is essential for your particular Oracle database. And system table space as well as the system auxiliary table space, these two are permanent table spaces. If they are not online and they are not available, then automatically you can expect that your operations to your Oracle database are lost. Am I clear with you? Now, every table space is a collection of what? Every table space is a collection of what? Collection of data files. Okay, every table space is a collection of data files. A data file always has finite size or infinite size. Any file in your computer has finite size or infinite size. It will be having finite size, okay? Because the size of the file depends upon the application through which you are actually operating. But in the current world of 24 by 7, 365 days when we are operating, we are continuously collecting the data or not? So when we are continuously collecting the data and we are operating through the process, then definitely I think we need to always understand the rule of the data as it goes on increasing in size. A file cannot manage the data beyond certain amount of limit. But the current technological requirements are demanding that your size of the data as it goes on increasing, your file size also should go on increasing, and any size of the file you should be in a position to maintain, because we need to maintain huge size files nowadays. Therefore, these table spaces, whatever you are speaking currently, they are called as normal table spaces. Starting from once again 10G onwards, Oracle has introduced one special kind of table space called as big file table space. These big file table spaces are very, very important, and I can say that these are the first level constructive facilities that are provided by Oracle towards the big data like world what you're speaking today. So big file table space is one kind of table space which is going to have the facility or ability, okay, which is going to have the ability to maintain one single very large data file. Okay, very large data file. Very large data file means the data file can be in the order of terabytes. The data file size can be in the order of terabytes, not just gigabytes. And your files internally, whenever they are managed, they are divided into blocks. We'll talk about these things later on. Now, when you come to the big file table spaces, it can contain a block size up to 4 GB. 4 gigabytes size of block can be there. These block configurations and the file size configurations and everything are done by your DBAs. So what is the fundamental advantage of the big file table space? The first constructive advantage is whenever we are going with the construct of managing the big file table spaces, it can always manage the maximum size of a single data file depending upon the configured block size. Means whatever block size your DBA is configuring, according to that, your big file table space will start managing one single file with a huge amount of size, where we don't need to create again and again multiple files and start getting into the criteria of scanning and IO increase. So I'm just giving a fundamental sizes what you can manage as block and what is the maximum size of the file you can maintain as one single file. If suppose like your DBA is configuring 8 kilo block size, okay, if your DBA is configuring 8 kilobytes of block size, then you can have one single file up to 32 terabytes. One single file. I'm making it very clear. You can have one single file up to 32 terabytes of size. Just imagine. If your DBA thinks that this particular size is not sufficient, then you can reconfigure the block to 16 kilobytes block size. When 16 kilobytes of block size is configured, your single data file size can go up to 64 terabytes. If your DBA thinks that that size of 64 terabytes is not sufficient for managing the data, then you can configure the block size as 32 kilobytes of block size. When your block size is 32 kilobytes, then it will be up to 128 terabytes. One single data file size can go up to 128 terabytes. In this way, as your block sizes are increased by the DBA, one single file size can go to the maximum of terabytes. You can just imagine how Oracle is promising its architecture to be ready for the current standards of distributed computing architectures that are highly discussed in cloud computing and your big data like implementations. Therefore, whenever you deal with your big file table spaces, it significantly enhances the storage capacity of your Oracle database. Because of big file table spaces, what is my advantage? The number of small data files I can reduce. So big file table space is always reducing the number of data files needed for the database. So because of the big file table space, we can simplify the database management by fundamentally providing data file transparency. In one single file, we can keep all the data that is essential through the process. So managing the data and handling that particular data will become much easy technically through the process. Now, whenever you deal with your Oracle database, big file table space are not compulsory. Okay, big file table space are configured by the DBA according to the size and the growth of your database. But system table space and system auxiliary table space are compulsory, and every database management system software like Oracle, once it's configured, it has its own temporary table space. This temporary table space is very, very important in your Oracle. The name itself is telling you this particular table space is fundamentally used for storing temporary data, which is generally utilized when you're doing some sorting operations. When temporary data gets generated, temporary data always gets generated when you are trying to sort the data, means order the data either in ascending or descending order. Whenever you're trying to do such kind of sorting operations, temporary data generation takes place. So this particular data will be kept into the temporary table spaces. Now these temporary table spaces are created by the DBAs at the time of configuring a database management system application. And for every user that is created in your Oracle database, he will be configured to one temporary table space. He can have multiple temporary table spaces, but at least one temporary table space he should be configured. And one temporary table space can be shared among multiple different number of users also. Those are all planned actions of your DBAs, but don't worry about that. So at the time of installing your Oracle and you're configuring your Oracle database, one temporary table space will be provided by your Oracle database. Okay. So you'll get one temporary table space from your Oracle database by default at the time of configuration. And by requirement, by analysis, your DBAs can create extra temporary table spaces as per the need of your database application. Try to understand this. So this fundamental information about your table spaces should be there in your mind, because you could be always cross-cornered by your interviewers on these particular areas. Are you getting me? If you are a DBA, they go more deep into the discussion of how to create, how to maintain, and manage your table spaces. That's totally a different construct. That's totally a different game. That's a different ball game. Be very clear about that. But as a database developer, as an application developer, you should have at least this minimum information about table space. There are many number of cases I have seen. Students come with Oracle database as experience and we ask them what is a table space. They just keep their face blank, because even if you have not created table spaces, being a database developer in Oracle, you should have the idea of information about a table space. Be sure about it, especially for people keeping experience. Be careful. The fundamental information, whatever you need when you say you're an Oracle developer, that you should have. Now, before we start working out, let us just catch up with the general architecture of your Oracle. It means the very fundamental layman architecture. Okay, the very fundamental layman architecture. If I am an application developer, I'll contact my Oracle database from my own user interface. Do you agree with me? That user interface can be anything like an SQL prompt, or it can be a front-end tool or XYZ, whatever it is there in the world. But all my data is in my physical side of my Oracle database. Do you agree with me? Now, this data that is existing in the Oracle database, only one user can use it, or multiple users can share and they can use it. What is your opinion? Hello? Are you there? Multiple users can share and they can make use of it. Now, suppose say like we have developed one project for one banking application. Within the banking application, the account holders information can be used by almost every employee within the bank. Do you agree with me? Yes. But this account holders information is available physically within your particular database, within the table spaces and data files. Am I correct? Now, let me say that I'm going and searching for one account holder's data in my physical database. Then my data should be read from my data files that are existing in table spaces, and then the data should be available in the runtime memory. That is nothing but RAM. Am I correct? Now, let us just think about one point now. Whatever data I am requesting, that particular account holder's data, another cashier or another clerk in a bank also may need that. Now, when I am spending some time to search the data in my database physically, now imagine everybody who wants the data, they are also trying to search the data again and again in the hard disk or within your storage device. It is definitely going to cost my performance or not. And it is going to create a heavy lot of load on my server. Am I correct? So Oracle's architecture is designed in such a beautiful way that it will make you come out of all these kind of issues. Now, internally, it's a very complicated architecture, but at least on a layman side, you should have some information about this. So the end user will start interacting with the Oracle's environment from a given user tier or a view layer. Okay, some user interface tier or view layer will be provided, and from there he will be communicating with the Oracle database. So you should always remember one point. The user tier or view layer is nothing but it is an interface from where the end user tries to interact with the database application, Oracle database application. Am I clear? Now, within our classrooms, that user interface tier, what we are interacting is nothing but our SQL interface. Okay, that is our SQL prompt, or you can say SQL command prompt, whatever you say, that's okay. Am I clear with you? Now, this user wants some data from the database, let us say. Actually, you are never given any permission to go and communicate with your Oracle physical database location always. So your request will be going whenever you generate any particular request. Okay, whenever you're generating any particular request, the request will start moving towards one special kind of memory that is available. As soon as your Oracle database server starts, we call that as system global area or shared global area. In short form, it's called as SGA. Am I clear with you? So as soon as you start your Oracle server, your server gets activated and it will create one special kind of memory that is part of your RAM. I'm making it very clear. It will create one special kind of memory allocation that is part of the RAM, where this particular amount of memory that is created as part of your RAM is called as system global area or shared global area. The name itself is telling you this system global area or shared global area will contain all such kind of data that is very regularly accessed and operated by the different Oracle database application users within that particular application. Means if I am first time I'm requesting some data in Oracle, now the data will not be in SGA. So the data has to come from where? Come on, the data has to come from where? From the physical database. Now, Oracle has one kind of intelligence. The intelligence is it will read all that particular data that is essential or that is requested by you. And after reading the data from the physical device, it will store that particular data in the SGA and maintains a copy within the SGA continuously till you do not try to shut down your particular server. Now, in your personal machines, you will shut down your computer very regularly. But in industrial applications, we don't shut down the servers at any point of time. So the data will be loaded and it will be kept in the SGA. Now, second time, say like you requested the data, which is not exactly same, but some amount of data you're requesting is same what I already requested in my Oracle. Now, Oracle never goes and searches the data for you in the physical table spaces. It will try to search the data directly within the SGA. If the data is found in the SGA, it will be returned to you from there itself. So the request always goes to the SGA. Now, whatever kind of data you requested, if that particular data is available within the SGA, then immediately the data will be returned to you from the SGA itself. Now, any operation that we are conducting on the RAM is faster or it's slower. It's faster. So Oracle always has intelligence to manage the historical state of your data that regularly gets accessed, and it maintains such data within the memory called as SGA. Be very, very clear about that. Okay. Now, what is the guarantee that every time you request the data should be in the SGA? Is there any rule like that? No. Why? Because I access some data in the morning, let us say at 8 o'clock, and that data I'm not using it again and again, and there's no request of demand on that particular data for say like some 6 to 7 hours. Oracle never keeps the data in the SGA because there's no demand on the data, so it removes it. So internally, Oracle is following certain kinds of algorithms, which are basically nothing but like least recently used, most recently used like algorithms are implemented by Oracle to decide whether the data what is available in SGA should be retained or it should be removed, and what is the timeline under which it should be retained or removed. It will be managing it. Am I clear with you? So that particular data what you're requesting is not available in SGA, then Oracle will try to push your request. Okay, Oracle will try to push your request. towards its middle layer architecture that is totally run by SQL star plus or logical layer or business tier that is managed by Oracle. Am I clear? Now here there are two things. One, your requested data is totally available in SGA. Then you get the request of information from SGA directly. Your request of data is partially available in SGA and partially not available. For that partially non-available data only, the request goes to the middle layer. Are you getting me? The request of your data is totally not available in the SGA. Then the request once again goes to the middle layer. In this way, many number of users could be requesting the data or not. Come on. In this way, many number of users could be requesting the data or not. So, what is exactly happening in SQL Star Plus? It is an area where your SQL statements are parsed and controlled by their operation. So this is the actual area where your entire SQL statements parsing and the way they should be executed. And if multiple users are executing the same SQL statement, then whose SQL statement should be responded by what data to which particular user. All this kind of logical information will be available in this particular construct. But I may be having only one request or multiple requests like this. In real time, we'll be having only one single request or multiple requests. Multiple requests. Now, these all requests have to be definitely served. So Oracle will be maintaining its own internal queue management services. Okay, Oracle will be having its own internal queue management services through which it will be operating that queue as per the requests that are coming in, and these queues are moved by priority of their existence. And this queue will be going and communicating with the corresponding physical tier where actually your data as per your request is stored and it is managed. So when you say it's a physical storage or it is anything like a runtime memory storage like SGA, everything in Oracle is under the control of table spaces. Be very clear about that. Now, I don't need to tell you that again and again. Okay, be very, very clear about it. Now, within your physical storage area, if that corresponding data is found, if that particular corresponding data is found, that immediately Oracle starts pushing this particular piece of the data. So your physical data storage is nothing but the area where your business applications physical state of the data is stored permanently. And this particular data, the moment it is found, this particular data, the moment it is fundamentally found, the data will be released to one special kind of component called as a dispatcher. So Oracle has its own queue and dispatcher architecture. Even though your operating systems will maintain their own queue management services and dispatcher management services, Oracle never depends on the queue management and dispatcher management services at the level of your OS. It practically overloads that particular architecture and manages its own queue and dispatcher mechanisms. Through the corresponding dispatcher, the data starts moving towards the middle layer. Are you getting me? Are you clear with that particular flow? And this particular data, then it will become a copy in the SGA first. So even though your data is coming, even though your data is fundamentally coming from the logical layer, at any point of time, this data will never be redirected directly to your user tier. This will never happen. And at any point of time, your user cannot directly contact your physical tier in your Oracle anytime. It's not possible. The whole architecture is working on a three-tier implementation, giving more security and more consistency or not. Now, this physical tier, whatever you are trying to see, once it returns the data through the dispatcher to your SQL starless environment, it makes the data to become a copy in the SGA, and then SGA returns that particular data to your user tier once again. Am I clear with you? And this is a continuous cycle that will be happening within your Oracle database, even if millions of users are getting connected in Oracle. And here one of the question a student can always raise is, so you said like SGA is in the RAM. Now, what is a guarantee that your SGA can fit the data that is in demand by the end user in the RAM totally? No, it's not possible. In such cases, Oracle internally has its own paging services. And through the paging services, it will send the data by quota. That's where your dispatcher is working. Now, if the system global area is not having space for new data, what happens? The system global area calls the least recently and most recently used algorithms to check which is the oldest data that is not in demand in SGA, removes the data and gives place for the new data automatically. If you're a non-computer science student, then also you should seriously understand these things. When I am a non-IT student is not an excuse for your existence in the industry when you want your job in the IT sector. Because I've seen majority of the times, especially students coming from the other branches like electrical, electronics, mechanical, and civil, when they sit in the interview rooms, they expect that we need to give them special attention even if they don't give the correct answers because they're non-IT. Sorry, no way such kind of indiscrimination will be there. Everybody will be treated that he knows IT, whether your academics or non-IT, that doesn't matters for us. Every day, whatever I speak, it should be considered very seriously for the next level of our discussions. And every day, what we are speaking will make a matter of understanding for tomorrow. So I could always say that our entire sessions will go in such a way that today what we are discussing is definitely going to be a criteria and composition of extension for tomorrow's class. Today you neglected, tomorrow you will suffer. In that way, the entire course will be going in that way. So whatever I'm discussing in these areas, I'll make them get more visualized once I take you into the practical side. And this physical storage architecture in the background will be in communication with your system global area on a regular basis. In a background, it will always be communicating with system global area, because any data that is not essential in SGA, that particular change of data should come back to the physical storage device once again. That is a layman's architecture that you can always consider, that manages your Oracle database when it is in a running statement. Am I clear with you? So all this architecture is operating upon one standardized principle, and that particular principle is called as relational model. So you like or you do not like, every database management system project in Oracle will be developed on a relational model. So you know relational model, you do not know relational, industry never cares. But once you say that you are an Oracle developer with SQL Star Plus, the minimum fundamental principles of relational model you are having or not, they will check. So the basic facts are what? The basic fact is it's a model that is first time outlined by a person by name E.F. Codd in 1970s. Now, anytime you say that you're working on a relational model, means you're working on relational database management system software, there are certain components that are definitely essential within the relational model. Therefore, you're learning Oracle from my class, your friend is learning MS SQL Server, or another one is learning DB2, or the next one is learning MySQL, that doesn't matter. The basic components of relational model are always same everywhere. The first thing is you are collecting the total amount of data for storage in the form of objects, where these objects are called as either tables, indexes, whatever you call, but anything in this model should be in the form of objects or relations that should have the ability to store your data. Every relational model software will provide you a set of operators that can act upon the relations to produce another relation. Means these operators will be operating on the data to produce the next level of the data what you need. A relational model is definitely expected to be having high level data integrity for accuracy and consistency. Means if you say that you worked on RDBMS software, every RDBMS software is 100% high level integrity and accuracy will be definitely guaranteed. Therefore, you come into the interview rooms and we don't find that integrity, accuracy, and consistency from you, then that can be an irritating point for us to select you. Any relational database will be storing the data, okay, should always use relations or two-dimensional tables to store information. Your total data is in two-dimensional state object called as tables in the form of rows and columns. Now, the rows in each database table should represent sequential values, where the value in the row should be an identified value in the business. Every value should represent definitely one identified criteria in the business. Be very, very clear about that. And every table will be having a set of columns which are controlling features of the business object. These columns are actually describing your object with the properties with which it will be existing. And every column, each column should represent a field of data that occurs consistently in each record or the table throughout the database. Means when you take a particular column, in that you will be having set of values that are representing a specific property of information of that object. And every column should be specified with a domain, where a domain is nothing but a set of permitted values for an attribute in the table. Means if I say date of birth, in that particular column only dates should be there. A specific type of data with respect to domain of data type should be collected over there. We utilize primary keys like concepts for identification of the objects in a unique way. Means for every record that you should identify uniquely, you have a component called as a primary key, and this particular primary key should be unique by its nature and it cannot have any missing values. We utilize some components called as foreign keys, which allow data searches and manipulation between the primary database table and other related databases. Means your data is interconnected in the business via the primary keys and the foreign keys as a concept. So what are these things? These are all things we have to practically implement. That's where we are making a journey to move now. Your relational database management system software should provide you a set of alternate names for existing database objects called as synonyms. That's a compulsory activity. Any relational database management system software should provide you a set of logical tables which are called as views, fundamentally which give you different perspectives for the same data with respect to different requirements that are arising within the business. And finally, a relational model should provide you indexes for promising performance and optimization of the data access in the concept of the data retrievals. So these all things what you have seen on my screen, they are very common and they should be definitely available as facility when you are going into any database management system software from any company by any brand which says that it is relational by nature. So if you are learning your SQL very perfectly by understanding all the rules of RDBMS, don't you think that you can work with any kind of database management system software that is existing in the world with any brand? It's one time concentration to make yourself and mark yourself with success. It just depends on you. So before we just kickstart ourselves into the criteria of communicating with SQL and start moving, now for any application that has to be developed, I think there is some seniors who are called as architects, analysts who are actually doing that core work, and as a developer you are following them. Am I correct? With such a huge lot of experience those professionals are having, how as a beginner you can understand their idea and executional standards that are demanded? That's where we'll just take a very small amount of an idea in tomorrow's session. When you deal with any relational database management system applications, what is exactly system and data modeling importance in application development? This itself is one individual concept of subject matter, which can be anything around 2.5 to 3 months of discussion. But I'll make it happen in just less than 20 to 30 minutes in tomorrow's class because it's essential for us to get that idea first of all. Okay. Thank you very much. Once again with you tomorrow. Have a nice day. Take care of yourself.